Today I'm going to talk about something that I don't know how about you. Where are you? I am in my bedroom. I've been locked in my bedroom for a long time. I was in my basement, but I've upgraded myself into a bedroom. And it made me think about because of this COVID situation, right? So definitely, and let me think about what's the role of humans in this world of IoT and AI, because I'm the lucky one. I can stay in my bedroom, still keep working, and my life, work wise, not very much impacted, right? So I miss my colleagues and so on and so forth, miss the coffee meetings, but again, I'm the lucky one. So it made me think about what's the role of human in this age of IoT and AI. So this is just let you know where I'm from for this presentation. My name is Steve. I'm the founder and CTO of SensorUp. I'm also a professor in the Rogers IoT Research Chair. So IoT stands for Internet of Things. And so my Rogers very generously sponsored my research group at the University of Calgary. I'm a lab scientist of a creative destruction lab. I don't know if you know about this, but if you don't know, check it out. I'm both in Rockies and Montreal. Okay, and then, yeah. So what is the role of humans in the age of IoT and AI? And especially I want to focus on the field workers, the frontline workers, so those who need to be outside. And then, we enjoy all the AI collaboration tools, predictions, BI tools in the office. But how about the people outside, and they are risking, exposed to a higher risk? And how can we help? That's, a big question I have. And I think you're familiar with this, right? This is our bird up data, and this is December. And then right now, actually, this data in December looks like a joke, right? But the idea is the case of COVID grow exponentially. And right now, we're all eager to waiting for a vaccine, right? And then things will be better again. But it seems it won't happen very, very soon. So I highly encourage you to read this article from MIT Technology Review. And actually, it's written by some professors at U of T and actually from Creative Destruction Lab. So actually, we have two kinds of solutions for COVID recovery. So how can we go back and then safely? Actually, there were some articles actually yesterday in news talk about this. Actually, it's an information gap. There are two solutions, so we can go back. One is more like a vaccine-based solution, right? So we get immune system get boosted, and then we can go back safely. But the other one is, what if we know what's going on? So if, for example, if we know who are tested positive, right? And then let's say you go to a hockey game, and then if we have a fast test or a very effective contact tracing system, so we know, okay, for whoever entered the hockey arena, actually they are tested negative, and as well as contact traced. So they are like they won't bring the COVID to other people, and then we can go back to work. So actually, if we can fill that information gap, the reason we cannot go back to work, we cannot go out and eat and play, is because we don't have enough information, so we don't know it's safe or not. But if we can fill that information gap, and then basically we can go back and to play, to live, and to work again, right? To have coffee, right? Again, I'm pushing to the extreme. But actually, if you think about it, I'm a researcher, right? But think about it. If we can fill that information gap, and then actually we can kind of go back, life can be more normal. Of course, one of the approaches to fill that information gap is contact tracing. And then I did a very simple Googling, and then it came out 10, 12 contact tracing systems. And I did a Google in June last year. So these are some examples last June. I'm pretty sure there are more and more. But when you have these different contact tracing solutions together, right? Let's say each company is using a different contact tracing solution. And then basically you are not filling the information gap. You are creating even more information gap, right? So this is something this is a IoT or information silo problem. But actually today, I would say not only in contact tracing, in many, many different areas. And this siloed solution, they exist. It's getting worse and worse every day. And actually, that's, COVID is one challenge. We need to fill the information gap, right? But actually, for a lot of organizations, or in order to run AI effectively, and you need to fill that information gap. But each IoT system, when you have different silo system, actually it's making this information gap problem even worse. So this is one example, is like the symptoms of typical complex physical operations, right? So for SensorUp, typical customers, they are running complex physical operations. And then typically they have this syndrome, right? They have IoT silo, but basically is they want to have fill that information gap. So they want to have visibility about their operation. So think about firefighters, think about a major incident, think about police, think about a complex industrial logistics, right? Like rail companies, right? So they want to have visibility, so they put a whole bunch of sensors, but they don't have visibility because they are all siloed, right? As a result, they're adding people, try to correlate data manually, and then coordinate different systems all together. And it's labor intensive, expensive, slow response, and costly mistakes, right? So imagine actually yourself, you are a sensor networks, right? You have multiple sensors on your body, right? So you have hands, your skins, you have eyes, your ears, right? Just imagine your different, sensing systems on your body. They do not talk to each other. They are siloed, okay? And then, can you even walk safely? Can you even go downstairs to have a dinner? No, you cannot, right? So, but today, this is happening every day in complex physical operations, right? And then for IoT systems. And then, it creates a lot of problems, right? No visibility, no early warnings. That means no predictions, right? And I'll touch on what do we mean by prediction later. And no automation, complicated process, ad hoc communications, and human errors. Okay, so here is our take-home homework. I'm a professor, so here's the homework. So 2 books, actually 1 book, 1 chapter. So the book is Prediction Machines, and the chapter is an article called How Smart Connected Products Are Transforming Competition. A great read. If we are in the same room, I'm going to ask whoever, who have read those books, raise your hand, but I cannot, but yeah, anyways. Okay, so what is AI? We'll talk about AI, right? And although I'm a professor, but I want to, I really like this, I'm a techie, right? I really like this angle and from an economist, okay? The book Prediction Machines is written by professors at U of T Business School. So here's their view about AI, okay? And how AI is going to transform and change the world, create value. So hopefully you'll find these perspectives quite refreshing. So in the future, when you think about AI, okay, replace AI with affordable predictions. Okay, if you train AI model, right, they are predictions, right? They give you confidence, right, about the prediction. So AI offers predictions, and now it's getting more affordable. So I remember when I was a student, a master's student, right, I took my first data mining class, right, and then learned the neural network, different algorithms, right, and then collaborative filtering, so on and so forth, right. It's the darkest hour of AI, actually, right, and it's not a very popular course at the time. I consider it as an easy one, but right now. At the time, actually, I remember to run an experiment, right? To run my algorithm, it takes days. Not days, hours. If it works, right? Because sometimes it just don't work, right? I need to run it again. So, but right now, today, it's getting more affordable, right? Things are more slow, right? So, replace AI with affordable predictions. Okay, so what do we mean by prediction? Prediction means taking information you do have to generate information you do not have. For example, you have a picture, a medical image, right? And then you classify, you try to, from the information you have for a medical image is a pixels you have. And the information you don't have, in this case, let's say it's a classification. That means to identify the tumors. To find out tumors and classify that they're good or bad, right? That's one prediction have. Today, who's doing that prediction? A doctor, radiologist. The doctors are doing that prediction. And that prediction is made quite expensive because the doctors are paid quite well. And then, but today's AI can make that predictions, training data and classify the images, right? And they become more affordable. So they become more affordable predictions. I give you one example. Actually, I joke with my civil engineering colleagues, right? So in the past, actually, in civil engineering transportation research, I need to count how many cars passing by that intersection by when they, have a new algorithm for that traffic light, right? They need to basically count how many cars passing by every hour, and before and after the algorithm. And in the past, they just sent starving grad students to count the cars, right? And yeah, but today, do they still need to send the starving grad students? Maybe they still, because they are cheap, but they can definitely use a AI to count, use YOLO, for example. Just put a YOLO camera, put a YOLO model, and then you can start counting, right? It's a prediction, right? The prediction is how many cars passing by. So this is AI, okay? The definition of AI. And then the use based on this, you can have, they have something called AI Canvas. So let me decipher this AI Canvas, unpack this, right? So first you have inputs. And typically, I'm biased, I'm an IoT guy. So typically inputs are from sensors, right? But in a way, yeah, so the inputs are, many inputs are from sensors, right? And then the sensors give you the input, so sensing. And then you have AI to make a prediction. And the prediction, so for example, if medical images, right, and make a prediction, good tumors and bad tumors. And so what? You still need a person to make a judgment. The definition of judgment is the risk of not doing anything. Okay, so let's say I have a prediction of good tumors, bad tumors, and they present to a doctor, and doctor decide, okay, should I cut it or not, right? The AI will not tell you that. You still need a human to make a decision. For example, you have a dispatcher, for example, right? Today, the dispatcher need to manually get data from different systems and try to dispatch a car to a place to, for example, moving some waste out. Okay. Today, they are getting a data, correlate them, and then make a judgment, which is what to do about that dispatch. But AI can make a recommendation, a prediction is like, oh, here are my recommendations about how you should dispatch different resources to pick up the waste. And then the dispatcher can make a judgment. Approve, no. Approve, no, for example. Okay. And then, so what is you have tasking. Tasking means you are doing some actions. And the actions will have outcomes. Let's say the tumor example, you have different tumors, cut it or not, right? You cut it, you have actions, and there will be outcomes. The outcomes will come back into the learning, and you make a new predictions in the future. And then the human make a better judgment, and so on and so forth. So this is really how AI should be run, or in a company, in an organization. So I really encourage you to think about that. So basically, the approach is you look into a workflow of your company, and then break them into tasks. And then think about, okay, can we use AI, basically the prediction tasks, right? So how can we use AI to make that repetitive, maybe sometimes boring prediction tasks? And then so remove the human from the repetitive prediction task into more like judgment role, right? Think about the poor, starving grad students sitting or standing at the intersection, breathing the dirty air and counting the cars, right? So that's definitely something can be replaced by AI. And then affordability is very important. So push to extreme, right? So when it's become affordable, right, we start to use things that typically we don't use. And then and that will create a bigger impact. Okay. So the next level is, let's imagine your AI, right? Your prediction, the predictions, you have a dial. You can really increase the accuracy or the power of that AI, the predictions, right? That's cranky up. So when you have the previous model, right, the predictions, right, and then today is not so accurate, it's fine. You think about what if I can make it more accurate, right, more powerful, and what's gonna happen to my business? Okay, so that's remember this, right? Let's use Amazon as an example. So anybody shop on Amazon? I'm pretty sure everybody shops on Amazon right now, right? So Amazon, they have this recommendation engine, right? Collaborative filtering or recommendation engine. So basically recommend you what you're gonna buy. So I want you to ask yourself, so how accurate is that prediction? 1%, 10%, 20%. That means 10% means, every 10 items they recommend to you, you might buy one, okay? So I don't know how about you, but for me, it's like maybe 10% to 20%. So let's remember, okay, let's crank it up to make it more accurate. And what is going to happen? Let's say you crank it up. Is the recommendation engine can recommend you, when they recommend you 10 items, you might buy 6. And what's going to happen? Okay, so what if that AI is so accurate? It's not like 100% accuracy, right? It's just like enough accurate, and it can totally change the way they do business. And that's the power of AI. So for example, let's say today, the tasks, right? The workflow when you shop on Amazon is shop, ship, and receive. That means you shop online, they recommend you, and you ship it, order it, they ship it to you, you receive it, and you return, right? But what if the recommendation is so accurate, they can change the way you shop, become ship, receive, shop. Instead of recommend you online, they basically ship the things they think you're going to buy. And so every day you open the door and then okay, 10 things Amazon recommend to me. And then you start to shop. Okay, so ship, you receive it, and you shop, and you return the things you don't want. If it's so today they cannot do that because it's not that accurate, right? But if it's so accurate, like 6 items, you will buy 6 out of 10, and they can digest the cost of shipping, right? And become ship, receive, and shop. And what's going to happen when that happens? Do you think you still need to go to Costco or Walmart? You don't need to go to any other places anymore, right? Because every day you open your door, woo, these are things I want, right? And they become more and more accurate. And the return, they can centralize the return, make it more efficient. Yeah. And what it's going to happen is they block all their competitors and create a dynamic shift and totally change the way do business. So if that happened, do you think it's worth the money to make that, if they can possibly do that, do you think it's worth the money to really push that AI and make this model happen? Yes. So that's the power of AI, which is not just about make one task better or replace that. Is what if you use an affordable prediction and then push to certain level, and you can totally change how you compete, and then wipe out your competitions, right? That's the power of AI. And of course, Amazon is doing this. They file a patent, anticipatory shipping, to start sending stuff before you bought it. And let me give you some example, not just Amazon. Let's say we're doing something about the waste, waste hauling. Basically, move the waste from one place to the other place, right? And then what if the trucks, the liquid hauling trucks, the wastewater liquid hauling trucks, they arrive before a service request? Okay, let me push a little bit. So let's imagine, let's say Uber. Well, if let's assume post-COVID, right? The Uber arrived at your doorstep and they say, "Hey, Steve, I know you're going to airport, and then so I'm here, okay? And then if you take me, I'll give you 20% discount." And if they have that prediction, right, so accurate, do you think you'll call Uber? Do you think you even need to call a taxi? No, you don't, right? Of course, I'll take Uber. You arrive and you predict, and then I'll take you. Right, 20% discount, right? So they just wipe out Lyft, wipe out taxi, right? If they have that prediction ability. So this applies to waste management as well. What if a firefighter, this is real, actually, we did this project with NASA Jet Propulsion Lab. What if every firefighter, they have digital assistants, and they warn the firefighter before flashover, so which is like combustion, right, in an enclosed place. And firefighters, when they are fighting fire, right, it's very busy, right? And what if the AI can assimilate the different data sources and warn, become a digital angel for the firefighters? Actually, this is the thing we are doing today. But when you push that extreme, right, you have all the data, IoT data comes together, and then you have the AI to digest it. And is it possible we can eliminate any preventable accident? And this is what I'm thinking about. Okay, how to fill that information gap, apply the AI, and then we can really empower the frontline worker, the field workers. And we are doing this, right? Totally change the way. So no more accidents anymore, and no more wait anymore, right? So how about you dispatch inspections and repair before equipment fails? Or, for example, today, methane leaking is a big problem for agriculture and oil and gas energy, right? What if we fix the leaking, potential leaks, before even the leaks happen and we become net zero emission? Yeah. So again, this is very important. And this is something we are doing as well. How to have that prediction by aggregating different sensor data from different systems and to really achieve that, right? Prevent the leaking of methane to the air. So our vision is the fabric interconnects the world's IoT data, empowering connected workers of the future, and apply automation and drive safety, productivity, and job satisfaction forward. And I think the job satisfaction is very important because, I'm thinking about this COVID situation, like how can we help? So I'll show you some example and make some predictions and show you some examples. So number one, everything will be sensor up. So sensors everywhere, becoming smart objects and offering unprecedented visibility and automation. I'll show you a video about COVID.
Hi, my name is Steve. I'm the founder and CTO of SensorUp. In this video, I'm going to show you this COVID module we configured based on our SaaS product. Our COVID solution has two parts. The first part is a digital map showing real-time and historical activities and risk levels of workforces and workplaces. SensorUp is sensor agnostic, and we can aggregate data from disparate contact tracing sensors, social distancing sensors, cleaning activity reports, locations of health supplies, etc. With the live and playback maps as the single pane of glass, decision makers can plan, track, and respond to emergent situations. But not everybody has the time to sit 24/7 in front of the screen. The second part of our COVID solution is a workflow engine allowing decision makers to automate workflows by assembling real-time tracking, sensing, and AI-based predictions and trigger events. In this demo, we aggregate 6 disparate IoT systems, including 4 different contact tracing beacons, video cameras with deep learning AI, and video plus microphones for cough detection. Here, we integrate an AI-based virtual sensor developed by the University of Calgary. It is able to sense how many people in the room, detect coughing based on video and sound, and even detect the event when the person who just coughed touched the door handle. Now, you are looking at the real-time digital map of the meeting room we just showed you in the previous video. As the people entering the room, you can see the risk level of the space is going up. We can configure different ways to communicate visually the risk level of the space. For example, each room has a capacity limitation. In this demo, when the number of people exceeds the capacity limit, the space turns red. And when the person who just coughed touched the door handle, the risk level of the room was even higher, and then the cleaning crew will be notified. And after the cleaning crew disinfects the space, the color of the 3D space turns back to green. All these events and sensor data are captured and stored and can be used for improving the effectiveness and efficiency in the future.
My next prediction is with IoT and AI, every process will be just in time. That means there will be no wait and no waste. And then I'm going to skip the video because of time, but we're doing something for just-in-time liquid hauling solution. Just imagine that a truck arrives before they even issue a service call, and then just automatically move that away, right? So the coordination can be done more automatically. And next one is all preventable safety incidents will be predicted and mitigated before they happen. And I'll show you an example we did with the Vancouver Fire and the US Department of Homeland Security, IoT-enabled public safety solution.
Hi, my name is Steve. I'm the founder and CTO of SensorUp. In this video, I'm going to show you our situational awareness solution based on our SaaS product. In a situation where every second counts, every decision could mean life or death, it's critical to understand where your responders are and what situation they are in so that they are fully protected, fully connected, and fully aware. SensorUp is sensor agnostic. We can aggregate real-time data from disparate sensors, including wearables, location trackers, environmental sensors, or even drone. With the live digital map as a single pane of glass, a real-time common operating picture can be established and shared so that decision makers can receive early warnings and make accurate and informed decisions. In this demo, we connected to more than 20 different sensing systems, including heart rate, indoor location, outdoor location, fall detection, body temperature, chemical gas, ambient temperature, and more. In crisis, nobody has the time to combine high-velocity data from multiple screens with SensorUp. Decision makers are only alerted when there's an issue or a crew member needs assistance. This allows them to focus on making the decision that matters the most. SensorUp's AI and stream processing engine is able to predict risky situations before they happen so that actions can be taken in order to mitigate the danger. After the event, all the sensor data are captured, can be reviewed at the hot rush, feed back into SensorUp's AI engine, and make it faster and better. First responder agencies also use SensorUp to protect first responders over the long term. Our solution can build a long-term health picture throughout career, each team member with data from different stressors, heat and gas exposure levels, and injuries. In summary, by combining disparate sensor inputs with AI, we are able to establish a common operating picture, showing real-time activities and predict emergent issues. SensorUp also build a long-term health picture to protect team members. To learn more, please visit sensorup.com.
So in conclusion, human is always the center of computing. And IoT and AI makes predictions so that humans can make judgment, and that's very important. And organizations can replace repetitive predictions with AI and empower humans to make judgments, will survive and thrive. And finally, empowering the connected workers of the future with AI and IoT will significantly improve quality, productivity, safety, and job satisfaction. And hopefully today I show you a glimpse about the future and how IoT and AI can help.
There is a large volume of unprocessed data coming through distributed acoustic sensing from seismic monitoring and raw data through ultrasound and RX images from pipeline instructions. You already mentioned leak detection, but from your expertise, is there any possible advice that you can share for possible applications of IoT and AI for seismic monitoring or pipeline inspection?
Okay, thank you. I think number one is let's apply to AI canvas, right? IoT canvas, right? As you said, we have the inputs from multiple sensors, right? The pigs, and then if you know the pipeline, they send pigs and collect data, and then and there's some electronic skins, right? And put on, right? And then so really the prediction is about leaking. Right, and today what they use is using differential pressures, right? So the one station to the other pumps, and the pressure is very different, and there's there might be leak, right? It's too late, right? And then, but actually, I would say today the problem is not about predictions. Actually, it's about data. It's very expensive to get those sensors, right? I mentor companies, and there are many companies try to solve this problem. I think the problem is not is still stuck at the sensor side. We don't have enough sensor data. It's very expensive, and a lot of these projects are brownfield, so that means it's very difficult to dig them up and then put the sensors in. So for a lot of companies, they just put, strategically put at the some places that might leak. But again, typically the problem when you find the problem serious is the place they don't think they're gonna leak. So yep, that's what's happening over there. But it's a million or billion-dollar question, actually. Yeah.
Can you comment on the value of domain knowledge in building AI applications?
I think that's super important. It's really about what are you gonna do? What's the what? Okay, if we go very high level, right? Is if you don't use IoT and AI, and you are gonna, you'll be dead. I mean, the company will be gone, right? Because your competition will use that, right? So it's really about analyzing the workflows and the tasks, and then think about how can you become more competitive by creating that dynamic shift. So imagine if you are a transportation company, right? Just imagine the future. If you don't have that prediction, but once your competitor have that prediction, you're gone, basically. So the domain knowledge is very important because you need to know, because you have million places to run your AI, but where to run and where to invest so that you get that competitive edge. I think that's very, very important.
If 80% of AI ML projects fail, what strategic advice would you give to founders and CTOs on how to get value from these type of projects?
Again, back to I'm pushing to the extreme, right? And my thesis about this AI canvas, right? So let me push to the extreme. Why do they fail? Right? If it's important enough, you just cannot fail. Right? If this is life or death, you just cannot fail. Okay? So I think it's very important to find what is life and death. What is so important? And then you just cannot fail. You have to invest or you'll be gone, right? It's like, remember, I always remember, right? Like 20 years ago, people are thinking about, do I even need a website? Do I even have internet? And then their prediction said, if you don't have an internet strategy, you'll be gone, right? So just look at how many companies are gone because they are cut. They cannot compete at the internet stage, right? So I think the very important thing is really looking into your workflow and then what's your business model right now, and think about how IoT and AI and to get you an advantage. If you don't do that, you'll be gone.
You mentioned that you work for CDL, Creative Destruction Labs there. I'm interested in the work CDL is doing in enabling startups. Is there a way to work or volunteer with CDL?
I'm a CDL scientist, and then my company actually went through CDL. So I raised my first round of financing in CDL without raising. So basically, it's an accelerator program. Okay, let me explain how does it work, right? It's like Dragon's Den. You apply, you were on the stage, right? And 25 companies started. And it's a mentor-based accelerator. So basically, the mentors give you advice, okay? And then 25 companies start, and typically it end up 12 at the end. So every time you have a company get eliminated because it doesn't worth the time. And you have the dragons, right? And the dragons are like, we call it CDL fellows and associates. And typically they start companies sold for many, many $1 million, right? So the people been there, done that. And that's CDL. So it's amazing for startup companies because, so why, okay, here's your theory, yeah? Why Silicon Valley is a center of innovation? Why? Because they work harder, they are smarter? No, they don't work harder. They are not smarter than us. It's because of funding? No. And one theory is this: they have more people been there, done that. So they can give you the judgment, human judgment about what are your priorities. And if you always know, for any companies, if you always know what's the top 3 priorities to do, you tend to be more successful. And CDL provide that, okay? And so amazing, okay, well, I'm going to say, totally transform my company. And then a way to work and volunteer with CDL, contact CDL. But, or you try to elevate yourself so that you can get into the room of CDL. It's one of the hottest tickets to get into that room, yeah. But great, I try to get as close as possible to CDL, right? It's amazing, and it's very positive. It's doing amazing things for Canada.
In the COVID risk example you gave, does it include flow setup of the building HVAC air circulation and airflow fluid dynamic models into the process of risk assessment for the entire building, or is it mostly restricted to the room region of specific risk assessment?
So that work is a research, yeah. We published a couple of papers from that. And then, so the reason we do basically is touch-based, right? So whoever you touch, yeah, and or interaction-based is because it's proven. There are literature support. That's a high risk, right? When you are, getting close to people, that's why we are staying in our bedroom right now, right? So they're higher risk. And then the risk of HVAC circulation and airflow, at the time at least, I didn't find literature to support that, right? Or how dangerous it is, right? So, but if it's high danger, definitely we should incorporate, right, and integrate, right? And those HVAC systems, they are sensored up. They do have sensors, right? So like there's a protocol called BAC or BIC, I can't remember. Yeah, you can get the HVAC data.